All right, so now that we've talked about inference for simple linear regression, we can go a little bit further and we can think about multiple regression. So the way that multiple regression works is that you can consider more variables as predictors in your model. So instead of just trying to predict the number of years of schooling someone completed based on the amount of schooling that their spouse completed, we're now going to use two predictors. We're going to predict how much schooling someone has based on the highest year of school their spouse completed and the number of brothers and sisters they have. So I'm going to write a linear regression model here. I'm going to call mine M2 because it's the second model that I'm making. And I'm going to use the assignment operator. And then I'm going to do LM, and I'm going to start with my response variable here, highest year of school completed, tilde, and then let's do one predictor, highest year school completed spouse. So far that's just the way we had done before. But now I'm going to do a plus, and I'm going to also include a number of brothers and sisters. I think that's how the variable is written. And of course I need data is equal to GSS. So let's hit the play button and just see if it gives us an error. Oh, it looks like it worked, so that's great. And then I can summary of M2, and I could hit the play button again. Okay, so now I have more coefficients in my output. I still have my intercept. I still have a slope for the highest year of school completed spouse, although it's a different number now because I'm fitting using more variables. It'll always change when I add more variables. And now I have a slope for the number of brothers and sisters as well. So if I needed to, I could write out the equation here. I could either do it kind of in a sentence, or I could get some of that fancy LaTeX code like I had before. Maybe I'll just do it as a sentence. So I'm going to say y hat is equal to 6.7. I'm going to round for the intercept, plus 0.6 all around times highest year school completed spouse, minus 0.1 all round times the number of brothers and sisters. So I could do that. If I wanted to, I could go find that LaTeX that I had from before. Let's see, just like this. And I could scroll down and paste it in here to make it a little bit prettier. So now I'm just going to change all these coefficients. 6.7, 0.6, and then minus 0.1. And if I wanted to, I could put a C dot, and I could say text, and I'll paste in number of brothers and sisters. So there we go. That's written out in LaTeX. So that's one thing that changes. Now we have more things in our equation. And if I wanted to make a prediction for the number of years of school someone had, I'd have to plug in both for the highest year of school their spouse completed and their number of brothers and sisters in order to get a prediction. But one thing that we might want to do is interpret these coefficients. And it's going to work much the same way as it did for simple linear regression, but we have to add a little phrase to our interpretation sentence. And that phrase is holding the other variables constant. So I will show you how this works. So we're going to interpret the highest year school completed spouse slope first. So I'm going to say for a 1 year increase in the number of years of schooling completed by a spouse, we would expect a person's highest year of school completed to increase by 0.6 years, holding the number of brothers and sisters constant. So if you had more variables, you would say holding, the first variable and the second variable and the third variable constant. In this case, I'm going to say holding the number of brothers and sisters constant. The other thing that I can say is holding all else constant, if I have too many variables that I don't want to write them all out. So for a 1-year increase in the number of years of schooling completed by a spouse, we would expect the person's highest year of school completed to go up by 0.6 years while holding the number of brothers and sisters constant. And similarly, for number of brothers and sisters, for a one sibling increase in the number of brothers and sisters, we would expect a person's highest year of school completed to decrease, and I'm saying decrease here because it's a negative coefficient, decrease by 0.1 years, holding the highest year of school completed by their spouse constant. So this is the main difference when you're doing multiple regression, is you have to say holding all else constant or holding the other variables constant. And the same sorts of things apply when we look at the output here. We've got our test statistics for each of the coefficients. We've got our p-values. It looks like highest year of school completed is a little bit more significant because this is times 10 to the minus 16th versus times 10 to the minus 5th, but they're both very significant because they have lots of stars. And I could look at the R squared and say, 37% of the variability in highest year of school completed is explained with this model that has these two predictors in it. So that is multiple regression. If you want to know more about regression, we actually have an entire course, Stat 320, which is all about regression. We spend the entire semester on it. I teach it pretty frequently, so you could take that and we'd learn more about it.